All right, good morning. This is our second video, and today we're going to be learning about the law of cosines. A little bit more difficult than the law of sines, which you guys learned in the last video, and got some good feedback. Most of you guys said that you understood the law of sines, and I was frustrated that the video length was too long, but you know, if it works, it works. But I still think that I need to find a way to shorten these. So in this video, I put some of the information on the board. And a little reluctant to do this because when you guys start your homework, you guys are going to start with what? A blank sheet, you know, with nothing. So, but I'm pretty confident that although the problems in the book won't necessarily be presented this way, where they give you a picture, they'll generally give you angles and side lengths. I'm pretty confident that you guys can draw the triangle yourselves. So, okay, let's get right to it. Over here on the side of the board, we have a triangle that's you know, arbitrarily named, angles A, B, and C. And then we have side length A, which is opposite angle A, side length B, which is opposite angle B, and side length C, which is opposite angle C. And again, this is our convention. And what does the law of cosines say? It says this. It says that side length C squared is equal to A squared plus B squared minus 2AB cosine of angle C. Okay? So what is this really saying? Oh shoot, I just lost lights. Okay, is that better? All right. Okay, back to what we were doing. Sorry for the interruption. C squared is equal to A squared plus B squared minus 2AB cosine of C. So in this case, what are we looking at? All right, this is what you guys have to pay attention to. You have to pay attention to side length C squared and cosine of angle C. Okay, so these two things right here. And I tutored a student once from Galileo that was struggling with law of cosines, and I'm thinking, why would you struggle with law of cosines? Law of cosines is easy. And it quickly occurred to me that they were not seeing this opposite relationship. So I did some thinking before this video. We'll see if this comes through clearly. But these two triangles on the board, you cannot use the law of sines to solve either one of these triangles. If you want to pause the video for a moment and give it a try, you're welcome to do so. In fact, I would encourage you to do it just to kind of get some questions in your mind. When does the law of sines work and when does the law of cosines work? And I'm going to give you a hint here. Notice that on this triangle, we know three sides of the triangle, and we denote this relationship as side, 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 meaning that this is the piece of information that we know about this triangle, the three sides. And on this triangle, we know two sides and we know an angle. And notice that the two sides are, notice that the angle is sort of between the two sides. So we're going to write this as side, angle, side. You guys may remember this from geometry. But if we read around the triangle, we read it as side, angle, side, angle, side, angle, side, angle, and so on and so forth. Again, over here, side, unknown angle, side, unknown angle, side. What do we know? We know the three sides of the triangle. So we denote this as side, 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 and we denote this as side, angle, side. And these are the two situations where law of cosines works and the law of sines does not work. I always say that if you have lots of sides, use law of cosines. Now, let's go ahead and set it up for this triangle. Notice that we have the formula over here on the board, and we're trying to connect the opposite relationship C squared with the angle C. So this is where you guys are going to have to look. If you have a side angle side relationship, then you guys are going to have to use this angle, the known angle, and you're going to have to call that capital C. Well, technically, you could write the law of cosines differently and call this A or whatever, but to make this simple and clear, just call the known angle C and call its opposite side lowercase c. And then you can, you know, name the 10 or the 20, A or B, it doesn't matter. But let's go ahead and call the 10 A and call its opposite angle A. Call the 20 B. And call its opposite angle capital B. Let me fix that. And let's go ahead and set up the formula. So what do we know? We know that C squared is equal to A squared plus B squared minus 2AB cosine of angle C. And you guys may notice that this looks very similar to Pythagorean's theorem. Notice that a squared plus b squared is equal to c squared. And in fact, it is related to Pythagorean's theorem, although this is not a right triangle. But what do we want to do? Well, let's fill in the information first. We know that we have to connect these two pieces of information. Okay, so c squared is our side squared. Okay, and in this we don't know the side, so we're just going to leave it as c squared is equal to, and then a squared plus b squared. So what's a? Well, we know that a is 10, so we have 10 squared plus b squared, which is going to be 20 squared, minus 2 times a times b, so 2 times 10 times 20, times the cosine of angle C, and angle C is what? 60 degrees. And I want you guys to notice that this relationship, again, maybe sum it up like this. This relationship, the opposite relationship here, you're going to know one of them, but you're not going to know the other. Either you will know the angle C and you will not know the side length, or like this problem over here that we're going to do in a minute, you're going to know the side length, but you will not know the angle. Okay, so let's go ahead and finish solving. Now we just got to solve this out. Remember that the equality divides the equation into 2 halves, so we can just focus here. And we're solving for c squared. Or no, we're solving for c. So we're going to have to take the square root at the end. Let's go ahead and do 10 squared plus 20 squared. That's going to give us what? C squared is equal to 10 squared is 100, plus 20 squared is 400, minus 2 times 10 times 20. We're going to multiply this together. And 10 times 20 is 200, times 2 is what? 400. Cosine of what? 60 degrees. Well, if you take the cosine of 60 in your calculator, you're going to get 1/2. So in this case, we end up with c squared is equal to what? 100 plus 400 is, we're going to add these first, 500 minus 400 times, and again, cosine of 60 is what? 1/2. Okay. Now we multiply before we add, so we're going to multiply the 400 times 1/2. So we end up with c squared is equal to 500 minus 400 times 1/2 is 200. And so we end up with c squared is equal to 300. And lastly, all we have to do is take the square root. We take the square root of 300. And this gives us that the absolute, I'm going to write it over here, the absolute value of c, remember that the square root of c squared is absolute value of c, is equal to, what's the square root of 300? 18 squared is 324, and 17 squared is 289. So we're somewhere between, I'll show you. 17 squared is 289. 18 squared is what? 324. And so if we look at the distance between these, that's a distance of 35. Okay. And we're looking at here. We're looking at 300, which is something squared. And we know that 18 squared is what? 324. The distance between 289 and 324 is 35. And so if we look at the distance from 289 to 300, that's 11. It's about a third of the way. And this is approximately a linear relationship. So we can guess this to be about 17.3 squared. So we can say that the side length C is about 17.3. You guys could just plug this into your calculator if you'd like. The square root of 300 is about 17.3. So what did we get for the side length C? We got 17.3. Now, your homework problems are going to tell you to solve for all of the angles and all of the sides, but I'm changing the directions and telling you guys just to use the law of cosines to solve for one side or solve for one angle. In this case, where you have a side angle side relationship, you guys are just going to solve for one side. And in the case over here, you're just going to solve for one angle. Okay? And then in the next video, I will go a little bit more in depth with it. So let me take this off the board. You guys can rewind it. Okay, so for the side relationship. In this case, you guys are going to have to pick a side to start with. Now, with the side angle side, you have to start with your angle as your angle C. But in this case, you guys are going to pick a side, and you're going to call it C. So how about we go with our 13? I'm going to call 13 side length C, and that means that opposite of that will be angle C, and these are the two things that we need to pay attention to in the formula. Now it doesn't matter for the other two. I'm going to go ahead and call 12A, call this A, call 10 side length B, call its opposite angle, angle B, and let's set the formula up. The formula says that C squared is equal to A squared plus B squared minus 2AB cosine of C. Okay? And in this case, again, we're focusing right here. The opposites. Okay, and what do we know? So let's go ahead and draw the line between the opposites. Maybe it would have helped if I had drawn that line here. But we know side length C, and so we're going to say that 13 what? 13 squared is equal to, and what do we have? A, which is what? 12, so we have 12 squared plus what? B, side length B is what? 10 squared minus 2 times A times B, so 10 times 12. No, 12 is A. 12 times what? 10 times the cosine of what? Angle C. Okay? And so this formula, or this equation is a little bit more involved to solve because you guys have to find the angle, which is going to involve an inverse cosine. So let's keep going. So we know that 13 squared, draw that line down the center of the equality. Remember, this is the left side and that's the right side. So the right side of the equation has a lot more on it. 13 squared is 169. 12 squared is 144. 10 squared is 100. Minus 2 times 12 times 10, so 2 times 12 is 24, times 10 is 240. Cosine of what? Angle C. And what do we now have? So we have 169 is equal to 244 minus 240 cosine of angle C. And I think I'm running out of room here. So what do we have to do first? Well, you guys are going to have to subtract the 244, and then you're going to have to divide by the negative 240. So let's go. We're going to move the 244 to the other side, so we're going to have 169 minus 244 is equal to negative 240 cosine of angle C. And 169 minus 244 is what? 75? 31 and 44 is 75. Yes, so we end up with negative 75 is equal to negative 240 cosine of angle C. And I'm going to finish this over here. Now what you guys have to do is you have to notice the negative 240 is multiplied by the cosine of C. You guys are going to have to divide by negative 240. You have to divide both sides by negative 240. These cancel. And you're left with the cosine of angle C is equal to negative 75 over negative 240. The negatives cancel out. You can divide each of these by 5, so we end up with what? 15. I'm just going to write 75 over 240. You guys could just go ahead and plug this directly into a calculator if you wanted it. If you divide 75 by 5, you get 15. And if you divide 240 by 5, you end up with what? 48 is equal to the cosine of C, which gives us, divided by 3, we end up with 5 over 16 is equal to the cosine of C. And to solve for C, you guys are going to now have to switch to inverse cosine. So, for instance, if you know that the cosine of 60 degrees, well, let's just, I'm just going to keep it simple. If I say that cosine of an angle, if I say cosine of theta is equal to 1/2, then to solve for angle theta, we know that theta has to be 60 degrees. To solve for this, you guys have to say that theta is equal to the inverse cosine of 1/2, okay? And notice, the unknown is the angle itself. Notice in this problem down here, the angle is the unknown. So what you guys are going to do to solve it is you're going to move the cosine. Let's go ahead and write it. Let's draw an analogy. You end up, with our problem, you have that the cosine of the angle C is equal to 5 over 16. So what do you guys have to do? You have to solve for the angle C by writing it as the inverse cosine of 5 divided by 16. And you guys can type this directly into your calculator and get an angle. And that concludes our lesson. So I will send you guys a set of 2 or 3 homework problems to practice, and we'll see how we do. But hopefully my goal for this lesson is can you guys just get the law of cosine set up, and I will be doing some tutoring over Google Classroom. So or not Google Classroom, but Google Hangout, where you guys can ask questions, because I'm assuming there might be some questions on this. Okay guys, have a wonderful day.